Varanasi, also known as Kashi, is one of the world's oldest continuously inhabited cities, a timeless confluence of history, spirituality, and architecture. This sacred city, with its iconic ghats, vibrant traditions, and its historic temples, embodies the essence of Indian culture and spirituality. Our project focuses on 5 historically significant temples in Kashi, funded under Science and Heritage Research Initiative scheme, SHRI, by Department of Science and Technology, Government of India. Through this initiative, we strive to uncover the science and artistry behind these architectural marvels, assess their vulnerabilities to climate and environmental challenges, and create immersive digital experiences to bring these treasures closer to the public and future generations.
So in our lab, we use the advanced digital technologies to bridge the gap between the past and the future. So we use photogrammetry and LiDAR scanning for the 3D high resolution documentation and of the temple structure and the ghats. We used to create the lowest part of the temple structure, and also we can create the replicas of the motifs and the ornamentation part of the structures for the easy study of analysis and the conclusion part.
We meticulously mapped and documented the selected temples, analyzing their construction techniques, motifs, and unique design elements by decoding their historical, scientific, and cultural significance. Using advanced technologies like photogrammetry, GIS mapping, and laser scanning, we created high-fidelity 3D models of these temples and their surroundings.
The 3D models and the mesh models that we are creating through these have been integrated in GIS, where we can analyze how the traditional temples have been interacting with their spatial surroundings. And these 3D models also help us to understand how how they are interacting throughout the year, so that we can analyze how the climate change is impacting them.
We conducted detailed studies on environmental impacts such as flooding from the Ganga, pollution, and seismic activities. Hazard impact diagrams were developed to identify vulnerabilities, assess risks to both the exteriors and interiors of these structures, and propose strategies to mitigate potential damage.
One such example is Ratneshwar temple, which is submerged in Ganga for throughout about 6-7 months, and it has been tilting. So when we are analyzing through a 3D spatial model that how the water has been surrounding the structure and how it is affecting, we will get a better idea of how to preserve these structures.
In the context of Banaras, we are studying the Nagara style of temple typology and referring the Sambrangana Sutradhar and the Manasara texts. We are extracting these rule sets that are delineated in these particular texts, and we are using that to create a computational model. Here what I am doing is I am creating a IoT based modular air quality and environment impact monitoring ecosystem. And this is the IoT based devices that I am using here. That will be addressing the environmental impacts on heritage structures.
We are trying to build a digital presence where the Indian heritage can be accessed globally without reaching there.
The immersive experiences allow users to explore these sacred spaces interactively, providing insights into their architectural details, cultural narratives, and historical significance. Finally, tangible models of the documented structures were created through 3D printing, bringing a physical presence to our digital work. These models now serve as educational tools in exhibitions and museums.
Looking ahead, we aim to publish books of our intense research and findings, and also host virtual museums, and also create a public presence not just in academic media but also in other domains.
Key outputs from this project include digital models and immersive experiences that are integrated into educational curricula, offering students and researchers valuable tools to study Indian architecture and history. Hazard impact diagrams that provide data-driven insights to strengthen resilience against climate and environmental risks. Public engagement programs including workshops and accessible virtual tours promoting awareness about protecting these invaluable structures. This project contributes to the broader field of heritage preservation by integrating technology and traditional knowledge. It aligns with the vision of future-proofing cultural heritage, ensuring that the architectural and cultural legacy of Kashi's temples remain intact and accessible even amidst challenges.